Okay, so we're going to go through a few of the tutorial questions from Physics 115, going through the set of questions that were set on the week of September the 15th. The first one is the electron volt, and you're asked in the question to define the unit of the electron volt and explain why 1 electron volt, 1 eV, requires, or is the equivalent of 1.602 times 10 to the minus 19 joules. Okay. So your first clue in this is the actual value itself. Hopefully this should look reasonably similar, because while the units are different and units are hugely important, you should notice this as being exactly the same numerical value as the basic fundamental unit of charge. So E is minus 1.602 times 10 to the minus 19. So reasonable clue that the charge on an electron is probably going to be in there somewhere, but they've suggested to you that you start off by looking at the force on a charged particle when it is in an electric field. And so that's a fairly simple expression. The force on a charged particle equals Q times E, which is the electric field. And so I always like to draw diagrams. Every physics question I'll always draw a diagram if you give me half a chance. So if we've got our little charged particle here, minus E, and it's in an electric field, which is going like this, then it will feel a force in the direction or opposite to the electron, or in the direction of the electric field. So to figure out exactly what that is, we need to know not only what the charge is, but also what the electric field is at that point. So we know what the charge is because we're talking about an electron. That's why it's called an electron volt, the amount of energy required to accelerate an electron through the potential difference of 1 volt. And we also know a way to re-express the electric field, as the electric field is the voltage divided by some distance. So going back to our diagram, if we've got some, I'm going to draw it this way around, some positive voltage here and some negative voltage here, then D is the distance between them, like that. But unfortunately, we don't know what the voltages are, we don't know what the distance is, so we're kind of out of luck. More importantly, even if we substitute this in here, we're still going to end up with an equation for force, which doesn't really help us, because we are looking for an equation for energy. But what we're really asking is how much energy is required to apply a force across a distance. And hopefully that sounds familiar, because it is the definition of work. So our work, the amount of energy it requires to apply a force on something like a particle over a distance, is your force times your distance. Hopefully you can see what's about to happen here. Our work is then just the force we've got up here, so QV on D times D. The D's cancel and we get left with QV. Now our Q here, because we're talking about an electron, is just E, which I defined up here, and our voltage, as defined in the question, is 1 volt. So therefore, the amount of energy required to accelerate an electron through 1 volt potential difference, the distances cancel, it doesn't matter, is 1 electron volt, and the equivalent of 1.602 times 10 to the minus 19 joules. Done.